Good evening, my YouTube viewers. In this video, what we're going to do is we're going to use ARIMA to forecast exchange rates. And so what we're going to do is we're going to model stock prices, exchange rates, and economic indicators. And we're going to write a program in Python to make this forecast. And in order to write the program in Python, what we're going to do is we're going to import 4 libraries that we're going to need to import to be able to execute the program. So the first library that we're going to import is NumPy as NP, which is a numeric library, and it also creates NumPy arrays. And then we're going to import Pandas as PD, which is a data processing library, and it also creates data frames and series. We're going to import matplotlib.pyplot as PLT, which is a visualization library. And from statsmodels.tsa.arima model, import ARIMA. So statsmodels is Python's statistical library, and TSA is the time series analysis module within statsmodels. ARIMA model is a module within TSA, and then ARIMA is the model that we're going to be using. And so what we're going to do is we're going to generate some synthetic data, daily rates over the period of a year. And then the first thing we want to do is we want to set our seed. And the reason why we're setting our seed is so every time we run the program, it will initialize to the same value. So it'll run the same every time. So your days equals pd.daterange bracket start equals 2023-0101, comma, period equals 365, comma, frequency equals days. So it's going to be 365 days. Trend equals 0.01 times np.arrange brackets 1, comma, 366. And that's going to simulate a slight upward trend. And noise equals np.random.normal. So normal is a normal distribution, bracket 0, 0.05, 365. So that means your mean is 0 and your standard deviation is 0.05, and it's going to be 365 is going to be your sample size, which is adding random noise to the system. So exchange rates equals 1.1 plus trend plus noise. So that's a base exchange rate with trend and noise. So now what we're going to do is we're going to create a data frame for the exchange rate data. So exchange df equals pd.dataframe brackets, curly brackets, date colon days, comma, exchange rate colon exchange rate. So your first column is your date, and then your second column is your exchange rate. And then exchange df dot set index brackets date, comma, in place equals true. And then so basically what that does is that takes the date column and that converts it to the index. And then now what we're going to do is we're going to split the data into training and test sets. So train data equals exchange underscore df, square brackets, exchange rate, square brackets, colon 300, and that uses the first 300 days for training. And test data equals exchange df, square brackets, exchange rate, square brackets 300 colon, and that uses the remaining 65 days for testing. Okay, so now what we're going to do is we're going to calculate the PDQ. Well, I've already calculated the PDQ when I ran this program, and it does take a long time to calculate the PDQ. But I've got the formula for calculating the PDQ hashed out. But if you want to use the formula, then what you have to do is you have to unhash it. And so I'm leaving it blank on the screen. So if you want to stop the video, you can copy the data if you like. But at the end of this, what you do is you print the best ARIMA, the RMSE, and the best config, best score. And then I've already done it, so I'm not going to do it again because it would take a really long time to do it. And then if you looked at my previous video on ARIMA, it takes even longer to do it for the ARIMA because you have the seasonality component, which is not in the ARIMA. So you're going to fit your ARIMA model. So model equals ARIMA, brackets train data, comma, order equals brackets 2, comma, 1, comma, 2. And then so basically what I did is whenever I calculated the PDQ and ran it, then it was determined that that was the best order to do it. And so you really do need to calculate the PDQ in order to get the best forecast. And model fit equals model.fit brackets. So exchange rate, forecast exchange rates for the test period, forecast equals model fit dot forecast brackets steps equals ln test data. So that's going to be 360. Well, it's going to be 65. And then forecast underscore index equals test data index. So you're going to use the test data dates for forecasting. And then you're going to plot the observed and forecasting exchange rates. So plt.figure brackets fig size equals 6, 4. plt.plot brackets exchange df dot index, comma, exchange df square brackets exchange rate, comma, label equals observed, comma, color equals blue, comma, alpha equals 0.6, plt.plot brackets forecast index, comma, forecast, comma, label equals forecasted, comma, color equals orange, comma, line style equals dash. And then now we're going to take a vertical line and put it in the chart to differentiate the training data from the testing data. plt.ax big line brackets x equals train data dot index square brackets -1, comma, color equals gray, comma, line style equals dash, comma, label equals train test split. And so now we're going to add labels, title, and legend. So plt.title is exchange rate forecasting using ARIMA. X label is date. Y label is exchange rate. The legend and the grid, and we're going to show it. So, and then so basically what we have here is we have the exchange rate forecasting using ARIMA. So you can see here the observed is in blue, and the observed is in the blue, the forecasted is in the orange, and the train test split is in the gray. So you can see that the forecast is just, we'll say 4.1, but that is what ARIMA model decided to do and how they decided to work it. So that concludes this video. The next video is going to be on another ARIMA. So I hope you decide to watch that video.